Hi. For those of you who have been e-learning recently, I am Mrs. Smith. I am the teacher who has taken over for Mrs. Davis. So it is nice to meet you. I am going to go ahead and start introducing some vocabulary that might be familiar from yesterday's lesson. And then we're going to talk about nets, which I will explain in just a second. So first we're going to talk about what a solid is. A solid is a three-dimensional figure that encloses a space. So for example, if you've seen a Rubik's Cube or just a cube in general, that would be considered a solid. Any three-dimensional shape. The face of a solid is the flat surface that's shaped like a polygon. And if you remember what a polygon is, it has to have at least three sides that are closed. So triangles, parallelograms, trapezoids, squares, rectangles, those are polygons. So the face of a solid has to be a polygon. With this diagram right here, all of these different sides are considered faces. Edges are the line segments where two faces intersect. So you'll see that I have all these faces labeled. Any of the lines where they connect are considered edges. So these yellow lines here are considered edges. Every single edge isn't labeled on this picture, so don't think that just because it's not yellow, it's not an edge. Any place where two faces connect is an edge. So if we have this face here connecting with this face here, it would make this another edge. A vertex or vertices, those are points where three or more edges intersect. So now I have three edges labeled here. We have our yellow edge, we have our red edge, and we have our blue edge. So the point where those intersect is called our vertex. So we've got this edge, and this edge all connecting right here. It would make this spot also a vertex. Let's talk about the difference between prisms and pyramids. Again, this is a little bit of a review from yesterday. A prism, the difference is that prisms have two bases, pyramids have one base. With prisms, all of the remaining faces that aren't bases, they are going to be parallelograms. With a pyramid, all the remaining sides or faces, other than the base, are going to be triangles. So let me show you what I mean. We have a pyramid here. Our base is a square, so that makes this a square pyramid. Now, all of the rest of the faces of this pyramid are all triangles. Then if we were to look at this triangular prism, we have two bases that are the exact same shape, and then all of our sides are parallelograms. So that's the difference in the two shapes. One base, two bases, all the sides are triangles, all the sides are parallelograms. These just quick major differences will be really helpful in if you ever are labeling shapes or trying to identify a shape. And whenever it comes to equations, it's going to be necessary to know if you're dealing with a prism or a pyramid. So let's move into nets. And by nets, I don't mean a fishing net or a butterfly net. I don't mean any kind of net other than a two-dimensional pattern that you can fold to form a 3D shape. So if you've ever heard of like a blueprint for a house, it's kind of like a blueprint for a 3D shape. Although you may not fold a blueprint for a house, but it still is like the directions or the navigation for how to get around a house, while a net is the directions on how to fold it to show you a 3D shape. So what does this look like? Here's a net for a cube. This is going to unfold in a couple different ways, but the first way, this is our first original net. It opens up and you can fold it back together. It goes from a 2D shape to a 3D shape. There's another way that that same net can be folded up to form the same shape, a cube. This next one is a net of a square pyramid. It's going to open up to the net, and then it will close back up to that 3D shape. So once it's unfolded, that 2D pattern is the net, and it will fold into a 3D shape. So I'll show you what I mean with my shapes here. So we've got our triangular prism. I'm gonna get this out of here, hopefully. Okay. Now, you've already seen the triangular prism put together. Now the net, I'm going to unfold the sides and I'm going to unfold the bases, and you have a net, a 2D shape that when folded up forms my 3-dimensional solid. So let's look at a different one. Here we have our solid, and if I unfold it, what shape do I have? What net do I have? When I fold it back up, I see that I have a cube. Net, (3D) solid. We're going to be working with a couple different shapes in this unit. We'll be working with cubes. We'll be working with rectangular prisms. We will be working with square pyramids. What I will say, and triangular prisms. But I will say that a rectangular prism and a cube are very similar, but a rectangular prism that has all the same length sides is a cube. If the length of the sides are not all the same, you have a rectangular prism. So it's just a quick tip, a helpful reminder. So that's the difference between the two. Rectangular prism, cube, all the same length sides. Okay. All right. So what you're going to be doing today, you are going to be doing for your independence a couple task cards. They're like multiple choice questions where you're going to have to match the net with the correct solid name. From yesterday's lesson, you saw the different shapes that we'll be working with, but I do want to remind you that the name of the shape is determined by the base of the shape. So if I'm looking at this pyramid, my base is going to tell me what the name of my pyramid is, and the base of my prism will tell me what the name of my prism is. So if it's a triangle, it's a triangular prism. If it's a pentagon, it's a pentagonal prism or pyramid, depending on how you look at it, or a triangular pyramid. So the name of the base will help you determine the name of the pyramid or prism. Okay, you know where to find me if you need any help. Good luck.